Okay, this lecture is about confidence intervals, and this is the first section on confidence intervals in Brace's book and most books, because we're estimating a confidence interval for a normally distributed random variable, most notably the mean, the mu of the population, when the standard deviation of the population is known. Now, when the standard deviation of the population is known, we're going to be relying on the normal distribution, because the sampling distribution of the x bars, as we know, is distributed normally with a mean that's equal to the mean of the population and a standard deviation equal to the standard deviation of the population divided by the square root of n. And it is the probability that we use of the fact that we end up between two standard normal random variables, a negative standard normal random variable and a positive standard normal random variable, when we've made this transformation, which we're very familiar with, to give us this. And this ends up with giving us some probability here. Now, this probability here that we're talking about, this becomes known as our confidence level. And our confidence level is going to be denoted with a very special type of notation. So let me write this down for you, confidence level. And this confidence level's notation looks like 1 minus alpha percent. And it's actually this alpha right here that our interval is relying on. So let me draw you a picture of what's going on here. So in our picture, we have the random variable here, and we have our mean, and we're end up here between these two with this level of confidence, right? That probability is right in there. And that's what this notation says here. So what that really means to us is that over here in this tail and in this tail together, there would be the alpha, right? And that means that this is alpha over 2 and this is alpha over 2. And those two alpha over 2 values, that's how we're going to end up finding this negative and positive z. Now, because we are putting this probability right smack dab in the middle, that means this positive and negative z are symmetric. They're the exact same value, just the opposites of one another. So what we end up doing here is using our inverse normal. What we're doing is we're finding the probability of some z being less than our negative z here, equaling this alpha over 2 probability. And that's basically how a confidence interval is based. So remember that this is the inverse normal that we talked about a few sections ago. So now that we have a little background on doing a confidence interval, now we're going to go ahead and we're going to learn how to do these. So what we end up finding is these z's, okay, these z's right here and here, and those z's, they have a special name. What we call those is critical values. And so when you hear someone say that they want the critical values, that's what they're looking for. Now, in Brace's book and some books, as other books as well, they'll have a table of critical values. I do not allow the critical values to come into a test in my classes, so don't become reliant upon any critical value table. What you need to be relying on is either the negative z or on your calculator using the inverse normal distribution to get those critical values. So let's scroll down in the notes here and let's take a look and see what we have.